Hello, everyone. My name is Laura Shang and presenting on Seattle, Washington. Today, I'll be presenting on evaluating LLMs for education, a comparative analysis of cost-efficient models in SAT reading/writing MCQs. My mentor is Jesus Valdivieso, and the reason I chose to present on this topic is because when I was preparing for the SAT myself, there would be times where my tutor didn't really know why the correct answer was correct. So I was wondering if LLMs and AI in general could help with this problem. So to start, the problem is that first, their library LLMs lack rigorous evaluation on SAT reading/writing tasks, especially on grammar and complex reasoning. The goal of this study is to identify optimal cost-efficient LLMs for educational assessment, and the reason it matters is because it enables scalable, low-cost tools for SAT tutoring/prep while exposing critical grammar limitations on the current LLMs. Here's a brief explanation of the data frame that I used. All the data is directly imported from the official College Board website for SAT questions. So first, all the questions have a ID, which is just a unique question identifier, and they all have a difficulty ranging from easy, medium to hard. And the type of question is basically the skill that the question is trying to test, for example, central ideas and details. There will be the question text, the four options, and then also the correct answer, and that's the entire data frame. Some more stuff about this Still's division. So the College Board website offers four different divisions, and each of the divisions have a couple of skills embedded in them. And for ease of analysis, I chose to only include the divisions and not skills. So here's my experimental design. I first started with the SAT exam. For example, here's an input where there's a question, there's four choices, and you're supposed to choose one. And then the LLMs I chose were SAT 4.1 mini, ChatGPT 4.1 mini developed by OpenAI, Gemini 2.0 Flash developed by Google, Llama 3.3 70B Instruct developed by Meta, Qwen 3 235B A22B developed by Alibaba, DeepSeek V3 developed by DeepSeek, Claude 3.5 Haiku developed by Anthropic. And basically, all the questions are fed into the LLMs three times, and then we record the answer that the LLM gives. So then, out of all those, the recorded data have the average variability, which is basically how many different answers on average did the LLM give for the same exact question, since each LLM was evaluated three times for each question. This means that average variability of 1 means that the model was super consistent in all its answers and answered the same exact answer for the same question. And an average variability of 3 meant that the model gave three different answers each time for each time it was evaluated for the same question. So it means that the lower it is, closer to 1, the better. And then we also recorded the total accuracy across all divisions of difficulties and types of questions, and then time taken to evaluate each model and the 10 lowest accuracy questions across all models. Here's basically the results graphed. Here's the average accuracy of questions separated by difficulty. And as you can see, Qwen had the lowest accuracy across all the models, while ChatGPT 4.1 and DeepSeek V3 had the same exact accuracy across total questions, which is 91.1%. And as you can see, there is a general trend where as the difficulty increases, the average accuracy drops, which is quite common sense. And then here's average variability as the questions separated by difficulty. As you can see, Llama 3.3 and Qwen 3 all had an average variability of 1 across all the models, meaning they were super consistent in their answers. And then all the other models had a varying bit of variability, with Claude 3.5 Haiku being the highest variability. So here is the average accuracy of questions separated by skills for the top three performers, ChatGPT, DeepSeek, and Gemini. As you can see, each model performed quite low on the standard English convention skill compared to their total accuracy. And then when you look at the average variabilities, you can also see that the standard English convention had the highest average variability for all three models, which could potentially mean that there is a lot more random chance in answering these models than others. So here's the evaluation time for all 90 questions. Qwen 3 had the highest evaluation time, while Gemini 2.0 Flash had the lowest evaluation time. Combining with Qwen's very low accuracy compared to all the other models, this meant that it probably has some systematic issues that needs fixing, and you should probably not use Qwen. Here's the distribution of difficulty for the 10 lowest accuracy questions. This is pretty common sense, but as the difficulty increases, the proportion of the question in the lowest accuracy questions increases. Here is the distribution of skill for the 10 lowest accuracy questions. Standard English conventions itself took up 70% of these questions, meaning that most models struggle with this type of question a lot. And then following it is the expression ideas and information and ideas. So to basically talk about the results, the top accuracy were the ChatGPT 4.1 Mini and DeepSeek V3 at 91.1%. Gemini 2.0 Flash was the fastest at evaluating all 90 questions at 94.5 seconds. All models failed grammar tasks such as standard English conventions with an average accuracy lower than 72.2%. And the accuracy drops sharply with difficulty. For example, ChatGPT had a 96% accuracy for easy questions and an 83.3% accuracy for hard questions. For next steps for this study, we could fine-tune the models on the lowest accuracy questions, such as the standard English convention questions. Another way we could do this is basically just feed it with more of these grammar questions and then embed more of the grammar rules into their infrastructure. And then another thing we could do is test LLMs on SAT questions with graph/data visualizations because this study excluded all of the questions that needed an image for the model to answer. And basically how I could do this is import the images into Google Colab, the platform that I use for evaluation, and add an variable in the data frame, which is the provided images. And I could basically have the models analyze them by using libraries like matplotlib or PIL to do feature extraction. Another thing we could do is evaluate the LLM's performance on GREs or AP writing prompts instead of MCQs. The input would be students' written responses and the scoring guidelines. And then I would update the prompts for the LLMs that would ask the models to find the parts of students' answers that would fit the guidelines. And based on that, they would generate a total score. And basically how I would find those data is by, of course, College Board shares a lot of the FRQ of the AP exams every single year. And using that, I could evaluate basically the accuracy of the LLMs. And of course, we would build API for the educators to embed the top models, for example, GPT or DeepSeek in tutoring tools for SAT prep. So to summarize the results, you should use ChatGPT 4.1 Mini or DeepSeek V3 for high accuracy feedback. If you want faster feedback, you should use Gemini 2.0 or Flash. You should generally avoid LLMs for grammar grading unless you can have human oversight. And lightweight LLMs show promise for SAT comprehension or analysis because ChatGPT and DeepSeek both had a pretty high accuracy. Here are my references, and thank you so much for listening.